Before passing here, the light shouldn't go on. Once inside this volume, we have the ability to turn this light on and off. Let's help with debugging. Let's say when the condition is active, we activate a signal on the screen that indicates it to us. Okay, let's save, compile and go try the scene. We enter the volume and nothing happens. Now let's get into this volume first. And it works, so the switch is on. Now we go into the other volume and the light goes on and off. Don't worry if the blueprints seem tough to you at first. By mastering them, however, you will find them very funny. Do not forget that also the example you saw in this lesson, you can find it in the additional resources. We have come to the end of these units. Now you know the Unreal interface, the various modules, and all the tools at your disposal. In the next unit, we will see how to use them to create the final project. Moodboard and storyboard. In this lesson, I want to show you the moodboard and storyboard that I created for our final project. When I have to carry out a project, I always start with a goal. When Domestika called me to carry out this course, I thought of it as a client and created their logo animation. I think of my projects, even the very short ones, as a story. In fact, in this case I made both a moodboard and a storyboard. Let's start by looking at the moodboard. The idea is to create a room for someone who takes the Domestika course. And I imagine it colorful. And someone who wants to make art. The moodboard defines the colors, defines the scene and the framing, and defines the flavor of our whole project. The moodboard, in this case, is the last scene of the final project, a large one in which we see the whole room and all the objects. With the moodboard in hand, you may already know which objects to start modeling. We will start with the vase. But you can start with any other object. From the cube, from the monitor, from pencils. Now that we have defined the design with the moodboard, let's see the animation through the storyboard. As you see, there are only 4 boards, but in the final project the scenes are many more. We don't care, because our storyboard serves to define the key moments of our scene. You can also choose to build a moodboard on all shots, but in this case it is not necessary. For me, the fundamental points of this animation are 4. The first is where objects are attracted from a single point of gravity. The second part is where gravity stops working and the objects start to fall. In the third, we see the objects falling into place. In the fourth, however, a wide shot, while the objects finish positioning themselves, and the room that goes back slightly. Making a good moodboard and a good storyboard. It is essential before starting to work. If you don't know how, I'll leave you in the additional resources 2 excellent links of 2 Domestika courses to create both the moodboard and the storyboard. In the next lesson, we will start setting up the project on Unreal Engine. Preparation of the project. In this lesson, we will see how to put order in our project, especially how to organize our folders in the content browser. Let's begin. The first piece of advice I give you is to work with order, and, above all, in the content browser. Generally, I make a folder for each type of object, imported or generated. So, in this specific content that you can download from the resources. Let's see how I preferred to divide the content browser. In a blueprints folder, where there are the blueprints that we will program. In the cinematics folder, there are all the assets of the content browser. Concerning animations, on maps there are all levels. It is good thing, for example, in a project like this, where will you go to model and then insert that object in the main layer. or where you will go to create the materials, create temporary levels in which to work. Egg. You can see in the project that I created modeling room. A level with basic characteristics, a sky and a floor, where to start modeling objects. After that, these will be generated in the generated folder. And from there we will sort them in the specific folder. So, make a map for each part of the processing. It is not a bad method. I find it useful for tidying up and not creating confusion. For example, in the level you are working on, have all those templates or get them and delete them. Because maybe the lighting system you use, it is not effective for modeling. Therefore, creating a layer, for example for modeling, is not a bad idea. Then, it is a good idea to create a folder with the materials, divided in turn into the master materials of the master materials, and all instances. Each time we go to generate a new material, we will first choose which master material is most suitable. Right-click, Create Material Instance. We give it the name, and then we put it among the materials. Then, to make even more order, we can divide them by type. But that's up to you, based on your tastes and ordering system. The mesh folder, which you can call it anything as you like, models or meshes within the objects we have modeled, to which we have already applied the materials, for example, the cup. With its applied material and its collision parameters. The Start Content folder is the one we imported automatically at the creation of the project, as you have seen before, and the Textures folder, where there are those few textures you will import. Another good way to tidy up is to work well in the World Outliner. You can choose your preferred system. I tend to create an environment folder, I call it ENV, within which we put everything related to lighting. Then post-processed material and the lights. Then you can create another mesh folder. But this is not the same. This mesh folder refers to the objects and meshes in the scene. Creating good folders really allows us to have order. Because we may have projects with a lot of things within the level, and leaving them scattered in the World Outliner could generate a lot of problems. You can also create subfolders. So maybe we are interested in keeping the whole structure separate. Compare it to the contained objects to create even more order. In the World Outliner, you can enable and disable the display of an object via this eye icon on the left. But it is important to remember that this only works in Editor. The moment you run the render, actually, this object will be present in the render. The only real option to trust to make an object disappear from the render is in the Details in the Rendering tab visible. Another thing that can help us a lot in editing the scene. It's about layers. To display the layer management window, just go to Window, Layers. They work with the logic of any other software. The difference is, as for the simple checkbox of the World Outliner, the layers do not affect the rendering, they are only used in the development phase. Let's see how they work and what they are for. We could create, for example, levels that refer to the left wall and the left sphere. And we can put them inside a level. So, we select them. Let's go to the Layers window, right-click. And we can create an empty layer or say Add Selected Actor to New Layer. The objects I have selected will be part of this layer, which we call left. We do the same thing with the right objects. We now have two layers, the right objects and the objects on the left. I repeat, this does not affect the final render. It doesn't matter which time you run the render, are enabled or disabled. Remember that all the resources I show you during the lessons, you can find them in the final project that I will leave you at the end of the course. In the next lesson, I'll show you how to create your first master material in order to create all the materials for the various objects on stage. Creation of the master material. In this lesson we will create our first master material, which will be the basis for all the materials that we will then add to all objects on stage. Let's begin. The master material is a material with particular characteristics that we are going to define and that we can then duplicate without having to redo or reprogram every time, and of which we choose which parameters can be customizable. The first example I can give is that of color. Create a material that has certain characteristics once and then duplicate it, and simply choose a different color each time to apply. Right-click in the content browser. Material. Let's call it master material. Simple, let's not define what kind of material. Double-click. Now the classic interface of the material editor is presented that we have seen in previous lessons. We leave the basic parameters unchanged. The material, let's define a color. Holding the 4 key, click, we will generate this node, which allows us to select the color that we are going to apply to base color. As you can see, I've already done it, but some advice I can give you is to create yourself based on the color palette of the mood board, your palette within this section. It's very simple, just select a color and then drag it into a new theme. Thanks to this arrow, you can create a new one. We can enable it and fill it with new colors. As you can see, I've already done it with the palette starting from the mood board to find all available colors immediately. Let's select the first one. We then go on to define the specularity of our material. My advice is to always start from a specularity of 0.5 and then modify it according to our taste. We can right-click on the node. Do promote to parameter. What did we do by creating a parameter? We have made sure that this value can be edited once we pass from the master material to an instance material. In the meantime, let's change the specular default parameter. From this section to the left, we set as default value 0.5. The minimum value will be 0 and the maximum value will be 1 because it is useless to go beyond 1 with the specular. We save. Let's see immediately what we have done. Let's go to our master material right button, create material instance. We have our own master material instance, but we rename it for convenience and we just call it instance. This instance was actually generated from this master material. Any changes we make to this master material, it will affect all the instances we have generated. Let's go double-click on the instance and we have our stuff, with the possibility to change the mirroring value. We can create several and assign a different mirror value. I would also say I can customize the color. So let's go back to the master material. Let's go to our color node. Right-click, convert to parameter. Let's give it a name, color. We save. Let's go see our material instance. Now there is also the option to change the color. Let's do some order, because in the parameter groups they are randomly placed with default values. The one in the interface is modified in this way. We go to a parameter, we define a group. We go to specular, we also insert the specular in the basic parameters. We save. Let's go and see our instance. And now we have created a nice tab, a nice paragraph of basic parameter. A very important thing, as we have seen with the material, it is definitely the roughness. For this project, we will use only one texture to move the roughness a bit. Plastic base 01. We don't connect it directly to roughness because we want to make sure that this is controllable, in the sense that it can be varied according to the material we create. L key on the keyboard. Let's create a linear interpolation. We connect this to roughness. And then we convert both the value of A of the lerp into parameters of linear interpolation, both the value of B. These will indicate one the minimum value of the roughness, and the other the maximum value of roughness. We connect roughness with linear interpolation. We can't connect to RGB, because only one channel goes into the alpha inputs. Let's start by converting this texture to a parameter, because maybe we can change it to another material. We create a group that we call roughness in turn. We always insert the other components in the same group. I recommend that you always set the minimum value of roughness to 0.3 by default, and the maximum value to 1. Let's see what happened. Let's save. Let's go to our material instance. We already see a beautiful variation of the material, which has a much more natural behavior than its own reflection. Now we can change it and vary it. We leave the same texture. We vary the maximum value of the roughness, and here the minimum. Now we can create any type of material with this roughness. But what is the other thing we are interested in customizing? Maybe the latter in this roughness, because we would like these details to be smaller or larger. To do this, we need to be able to modify the tiling. That is, times when this texture is repeated on the object. To do this, we work on this input node via the text coordinator node. The tiling value has 1 and 1, it repeats once. To better understand what we are doing, for a moment I'll apply our roughness to the base color. Or, another very useful thing. Right-click on the node, Start Preview node. So we see in the preview on the left only the result of this node. If we repeat the texture twice, we see that it becomes smaller. Let's repeat 10 times. Let's exaggerate. We see that the texture is repeated many times. How do you check this parameter? Meanwhile, it might be useful to separate the two parameters x and y. That is, how many times I want to repeat it vertically and horizontally. Meanwhile, to control the parameter you need a multiply node that we connect to the roughness output. Let's create a parameter for the a value of the multiply node. And let's see what we've done. We see that as this value increases, multiply the times we repeat this texture. For now, let's try to control the x and y scales separately. At this point we need to add an append node. And tie it to the multiply knot. It will give us error for now, because we still have to configure the nodes. We're going to call him xTile and yTile. By default, I'd say 1 for both of them. Let's create a group. Texture tile. We tidy up because we already have knots that can be confusing. As with the blueprints, we can comment on our node groups. We select C button tile. And we have already done a little more order. Let's see how to customize the project's normals as well. We apply a normal. We introduce the concept of switch. That is, we do not want all our materials to have normals, so we need to make sure to enable or disable this node to our liking. To do this, the switch node comes towards us. Not this type of switch, but simply the static switch, which returns two different values based on the value of value, which can be true or false. If we are going to create a variable from this node, we see that this, unlike the other green, is red because it can only have two values, true or false. If this value is true, pass the node we connected to the true node. So in this case the normal. If this value is 0, i.e. false, the value of false is authentic. In the meantime, let's go and give some names. We call this value useNormalText. And we create a group that we are going to call normal. NormalText. It must be assigned to the normal group. We must now create the false value, that is, a flat texture, therefore smooth. To do this, I usually generate a color where the value of blue is 1. Corresponds to a flat normal. We save her. Let's open our instance. And we see that we now have the normal parameter. Why is it disabled? Because we have left this boolean as the default value, a false value. Once we go and tell him that value is true, the map of normals comes into operation, this one. Let's see what happens if we give this false value. Our material is completely smooth. We can then change this normal, another one. There is only one thing left to do, that is to make sure that the normal can scale according to tile's parameters. We connect the multiply node of the tile. At the UV entrance node of the normals, we save. Let's see that the value of the normals also changes. If we go to change the value of the tiles, since we have added the append node, we can manipulate independently. We now have our master material working with everything we need to create all the materials for our project. It will be enough for us, from time to time, to go back to our master material. We create our own instance material. We apply it to the object, and let's change the parameters that interest us. Color, specularity, roughness parameters, tile values, and, in case we are interested, the normal ones. Now that we have our master material, we can move on to the next unit, where we will model the first objects. We will place them in the scene, and we will light it up. Model the flower pot. In this unit, we will start modeling the first objects on stage. Let's start from the jar, using the tools we have seen in past lessons. Let's go. Let's start modeling our first object now, especially the vase that we have already seen in the mood board on the right. After activating the modeling editing mode bar, we drag the Type B sphere onto the stage. You can leave the standard size and standard settings. Click on Complete. And go to reset its location from the Details panel. We set 0 of location and 0 of rotation. You may already notice that in the generated, Unreal has already saved this first step of our mesh. We select our sphere from the world outliner. And let's apply the pin cut tool. Let's get to the side of the object. Let's say that a cut of this type can be fine. Now let's activate the Polyedit tool. Select the first polygroup at the top. And we try to do an internal extrusion with the Inset tool. Then we select the other polygroup that has just been created, and we are going to extrude it upwards. We select the internal polygroup and we simply move, without extruding, this time, the polygroup down. Let's say our vase is almost done. To help us visualize, we can already start applying the material. To help us visualize, remember to save often with Ctrl+S or Ctrl+Shift+S. Now we can move on to modeling the flowers that will be inside the jar. Starting from the stem, we will use a cylinder. Here, however, we should increase the subdivisions regarding the height. We could set the view to wireframe. I would say a subdivision of 40. Let's go back to the normal view and reapply the cylinder, which now has the subdivision on 40. And we set it. Model, always following the models in the coordinates 0, 0, 0. It makes our work much easier. Indeed, in this case, we moved the stem to 0. We can use such a sphere again. Once the sphere has been brought into the coordinates 0, 0 and 0, we raise it up above the stem and try Home or End on the keyboard. This snap will automatically activate and position the sphere above the stem. Let's go and climb it. At this point, let's duplicate this object. We can do it directly from the viewport, holding down the Alt key and dragging the object along an axis. We place the second sphere like this. We select them both and activate the Boolean function. On the left, we swap the two objects, because B subtracts from A. And we will get our flower. The objects are still editable, because before clicking on Accept, we can edit and see in real time the Boolean reaction. We apply and we have our flower. At this point, we can select the stem and the flower. And we can join them together with the merge tool. We now have only one object. We can rotate it 90 degrees. And here too we can apply a material to help us visualize. At this point, we must already go and see in our content browser. In the generated folder, what are the files it created? Because we must immediately understand what they are and give them the appropriate name to identify them. We click on the vase in the viewport. Let's go to the world outliner, right-click, browse to asset. This will allow us to select the object in the content browser that we have in the world outliner and therefore also to identify it. At this point, I'd say rename it to vase. We do the same thing with the first flower. Right-click, browse to asset. And we call it Fiore 1. We duplicate flower 1, but not in the world outliner. Right from the content browser, because we have to reinsert it and deform it so as not to deform the object we just created. A good thing to do is to change the pivot. Thus we have the correspondence with the other flower. We rotate it 90 degrees. And let's apply its deformation with a warp type deformer. The warp type deformer looks like this, with a gizmo that allows us to rotate the deformer to set the origin of the deformer starting from the bottom and the end of the deformer to the top. This other handle, on the other hand, controls the intensity of the deformer. With each change of this handle, the corresponding parameter in the options section will vary. Let's go to accept and apply the deformation. As you can see, the second flower duplicated in the content browser. It's modified, and that's why we duplicated it at the beginning. We also apply the material to him. Now we duplicate it, this time from the world outliner. Edit duplicate. Let's go and mirror the object, scaling it by -1 on the x-axis. In order to have this composition, now we can do this. Select these three objects and click Merge again. We can already apply the name. Accept and let's look in our generated folder. And we have the flower object. Another thing you can do in the content browser is to set the preview of these thumbnails. Click on the Settings button. Thumbnail Edit Mode. Go to the thumbnail and rotate as desired. At this point, we can save everything. Delete all meshes generated during modeling. And go to correctly configure the materials from the object editor. Now, once the default materials have been set correctly, and once you have given the correct name to the files, you can remove them from the temporary generated folder and move them to mesh. The reason we modeled these two objects separately and we did not merge between the vase and the flower, it is because later on, we will animate them separately. Now that you've seen how the flower pot is modeled, we can move on to the next objects, the cup and the pencil. Modeling the cup and pencil. The time has come to model the cup and pencil. Let's begin. Let's start with the primitive cylinder. Don't worry about this glitch. This is normal and depends on the video card you have installed. Let's make sure, in the shape settings, to set the slices between 50 and 60 subdivisions. La radial slice. Once set to 60, let's create our object. And we bring it to center stage. We can climb it. And now let's go create the rubber. We always move the coordinates to 0. To obtain a geometrically correct result, we can change the pivot of the cylinder, placing it on top. Let's now change the pivot of the sphere. And we place it in the center of it. We take the sphere, we relate it to the cylinder, and we set its local coordinates, therefore with respect to the cylinder, to 0. Now, the center of our sphere is positioned exactly on the edge of the cylinder to form our rubber. We can change the view. Position ourselves on a more suitable view for the next operation. And we cut the part of the sphere that we do not need. Then we will use our pin cut. With the flip plane command we will reverse the cut. Automatically, Unreal applies the cut in the middle of the geometry, and therefore the operation can be considered finished. With the pivot positioned correctly, we can decide that this gum is not exactly round, but it is elliptical. Now let's build the base of our pencil. Let's start with a primitive cone. We set it like the other two objects. We set its coordinates to 0. We rotate it 180 degrees. And we bring it closer to our geometry. We position ourselves on a more appropriate view. Let's match these two geometries. Let's scale this geometry like this, and apply no slice to it too. I would say this way. We can duplicate the rubber and use it to create the tip of our pencil. Now let's select all the features in the scene and apply the merge command. As we have seen before, creates a single mesh from the selected meshes. Now we need to apply the right materials to the various sections of our pencil. To do this, the Material Editor tool comes to meet us. To avoid the glitch above, we select our viewport in unlit mode. We select the object, Material Editor. At this point, the first thing to do is to select the materials we want to use right from the start. We need of the top, the central body, the tip and this other part. Let's add a material by clicking on the plus icon. Let's go and choose another material. You can use both this window and drag the material from our content browser, which is perhaps the most convenient way. Let's go find the fourth material. First, let's say we will use this material for the central body. First, we need to say what material we are applying. Select Material 0. Let's select all the polygons that interest us. When we are sure the selection is right, click on Assign Selected Material. Let's go set up the second material. Then we select one selected material. We select the geometry that interests us, to which we want to apply that material. We need to reduce the width of our brush a little. Otherwise, we cannot select the geometries that interest us. Brush size 0.1. Let's go to Select. With Shift we go to deselect the polygons. And now we can assign this material as well. We already have the material. We select the polygons that interest us. Let's apply these two. Let's move on to the last one. Double-check that the selected polygons are only the ones you want to apply the material to. Accept to confirm our operation. I would say that we are there. What happened? Let's look in the generated folder. As you can see, there are the usual temporary files that we can safely delete. Let's go open the geometry we created. Unreal has done nothing but create a single geometry. So he created 4 material slots assigned to the polygon selection we have chosen. We can change them at will, and they will only change in the polygon selection we have chosen. Now, we just have to change, as usual, the name of the geometry. Delete temporary objects. And move our object to the mesh folder. There we will find it to reuse it in all the scenes in which we need it. At any time, we can take our pencil object, bring it on stage, and that's it. Let's see now how to shape the cup. To do this, we will use the Path Revolve tool. I disable the display of the floor of this geometry because it would get in the way. Path Revolve presents us with this grid, where you can draw a spline and apply an extrusion around the revolution of the x-axis. In this case, we click on a point of the grid to start drawing the spline. At this point, before clicking on Accept, we can optimize our spline before actually making the geometry no longer editable. We can also select points with multiple selections. This gizmo will appear, which will then allow us to move it. In this case, I would say to increase the steps of this extrusion to avoid this jagged geometry and make something softer. I would say to select explicit steps and decide how many steps for the extrusion we have to generate. 60 is a lot, but we don't have any performance issues, and we can get this very soft geometry. We click on Accept and we have the first part of our cup. Now let's go create the handle. Let's start with the primitive torus. We decrease the size. We increase the subdivisions to create a softer geometry. I would say it can go and we can climb it later. We stage it, we set the torus to 0, 0. There is a problem because the torus center. It is not the center of our object, because Unreal automatically pivoted this way. We also reset the rotations and we go to modify that parameter to be able to insert the geometry in the most suitable way. Our pivot tool always comes to meet us, and we apply it to the center. At this point we can rotate our object 90 degrees. We set the other rotations to 0. At this point, we can climb it however we like. And, even in this case, we can cut it with the slice command. We just have to do the merge of geometry. Apply a material. Give the right name to our geometry. Save everything. Throw away the excess items. And save the cup in our mesh folder. Now that you know how to model the first 3 objects, know the techniques to finish modeling all the objects on stage, but don't limit yourself to that. Think of some interesting object that comes to your mind and add it. In the next lesson, We will start setting up the first volumes and to insert the objects we modeled into the scene. Insert the objects into the scene. The time has come to start putting our objects on stage and give life to our project. Let's begin. Now we are going to create our level. And we will insert the objects we have modeled inside. The ones we are going to recover from the starter content we installed. Let's create a new level. Right-click in the content browser. I recommend in the right folder. Level. Let's assign a name to the layer. We haven't entered the level yet because we have to double-click. It asks us to save the current level. In this way, as we saw a few lessons ago, let's create a completely empty layer. Always remember to refer to the mood board and the storyboard. We need a uniform background, which is not affected by the lighting of the scene. Let's just take advantage of a particular object, which is found in the starter content that Unreal offers us already made and preset. In the Search tab, type Sky. The object that interests us is Skybox. Double-click on the object to go and analyze it. Skybox is a huge sphere with a very large diameter, which has the normal reversed, that is, the visible face is the internal one. Because let's insert Skybox into our scene. We place the coordinates 0, 0, 0. First, I recommend that you lock this object, because working in the scene and with the other objects, you will select it very often by mistake. Lock actor movement. Now we can neither select it nor move it by mistake. Now we need a uniform material. I have already created it. Let's analyze it. It's very simple. The material we will apply to the background is an unlit type material. Select this node, the final node of the material. And let's go see the properties. Surface type, opaque, but the shading model, unlike the usual which is lit, in this case it will be unlit. It means that it will not be affected by lighting and shadows. It will have a constant color and will not be affected by lights or shadows, nor any other rendering effect. The channels that remain exposed in this case, they are only emissive color, world position offset, and pixel depth offset. We are interested in emissive color. From our palette we take the correct blue, and we insert it in the emissive color node. Let's save and go out. We select from the world outliner Skybox, drag the material. To understand what happened, it is necessary to insert at least one other object in the scene. Let's see this cube. The behavior of the Skybox is perfect. It is a uniform background. Before inserting the objects into the scene, we must at least create an environment or some lighting system that can help us model, and that it will be temporary anyway. I recommend a directional light, not perpendicular. And to create a post-processing volume. We will see it in a few lessons. For now it's a kind of general level check. With regard to post-processing, then exposure, color grading, etc. We insert the directional light in the post-processing volume in a new folder that we will call envtemp. Because it will be a temporary lighting that we only need for modeling, it is important that the post-processing volume is set with the value of infinite extend. It means that it affects the whole scene, and not just inside the volume. We are going to modify a single parameter which is precisely that of exposure. The advice I give you is to do a basic type exhibition, where the highest and lowest exposure are at 1. so that there are no variations when the room is moved. At this point, we increase the effectiveness of the light, I would say 15. We have a temporary enlightenment that allows us to move forward. Now we can start inserting the objects into the scene. Starter content comes to our aid right away, in the architecture folder. I would say we can enter wall 500 x 500. We move the center as coordinates, that is 0, 0, 0. And we rotate it 90 degrees, so that it becomes our floor. Then, I would say that as a window we can use wall window. We also rotate 40 degrees. And we move it to the coordinates 0, 0, 0. We can both make the two geometries interpenetrate, that with a snap, as you will remember from previous lessons, by selecting the central dot. Let's make the object slide on its pivot relative to the surface of the other object. And then, by hand, we go to position it correctly. It is not important to be precise, but if you are, it is much better. We also duplicate the floor to make our wall. Please always refer to the mood board. Let's start adding some material. It helps us not to get confused. Obviously, the lighting will make these colors a little weird. But we will see it in the next lessons. But this already gives us an idea, at least it helps us not to create confusion, since if it's all white you can't get your bearings. In addition to the material that we find in the starter content, in addition to those that we have generated, the meshes we modeled, like the vase we saw together. We can also start from geometries and bases that Unreal offers us as the cube to make the skirting board. Here too, as in all cases, it is a good idea to make a little order and maybe create a folder with all the meshes. The skybox is the only one that is not temporary, and put it in the env folder. By order, we can still rename all objects. We can group them, relate them, create subfolders. For example, these two cubes we could call them skirting 1 and baseboard 2. Create a folder. We can also create a folder for these other three. So everything is more orderly. Remember to save often and remember to do it with Save All, or with the shortcut Ctrl plus Shift plus S. We can start inserting the objects we have modeled. So, let's start by entering the table. If you have positioned the pivot well during modeling, now placing objects will be much easier. As you can see, the positioning will be really immediate when the pivot is thought out in the right way. In this case, at the base of the monitor that hooks perfectly to the table. The assembly of the scene is almost immediate. Let's see what happens if the pivot is set incorrectly. The book sinks because the pivot is not at the base of the book, but it is at the center of it. We can fix it, as we have seen in the other lessons, thanks to the Mode toolbar, that is the toolbar of the modeling system. We select the object, we enable the modeling editing interface. And let's look for the pivot function. We place the pivot here on the left, at the bottom of the mesh bottom. We accept the change. We can close the toolbar. Now that we have the pivot at the base of the book, we select the dot. And, automatically, it will snap to the first mesh. As you can see, assembling the scene on Unreal is a lot of fun. Let's see, instead, objects that will be animated separately. Like the vase. The vase is made up of the actual vase and the two modeled flowers. We take the first flower, we make it the child of the vase. We set the relative coordinates to 0, also the rotation, and this will position itself perfectly in the center of the pot. Let's take the other flower. We do the same thing, we always relate it to the vase. Let's set its coordinates and rotation to 0. And then we duplicate it. Paying attention to apply a scale on the z-axis of -1. In order to have it mirrored. Then we can take two side flowers, to relate them to the main flower and to raise it up. We apply the right material. We can do it directly from the viewport, which is very convenient. Why did we do this? Because in the animation phase, we will need to move this vessel indiscriminately from the flowers inside. But the flowers will always have to follow the movement of the vase. In this way, even to position and scale it, we should just scale the vase object. And all the children inside will behave accordingly. Unfortunately, working with stairs and the internal modeling system, it is quite complicated and almost not worth it. It is better to climb objects by hand if you are not doing architectural precision work, but we are not doing this and we can afford it. Different types of approximation. You can have fun assembling the scene and applying the changes you want. Now that the objects are all in place, we just have to illuminate the scene. We will see this in the next lesson. Illumination of the scene. So far we have modeled and inserted our objects on stage. Now we need to enlighten everything. To do this, we will use the light seen in previous lessons. Let's go. Once everything is in place, we can start having fun with the lights. Perhaps it is one of the funniest and most dynamic phases of all the work on Unreal. The first thing to do is to enable the Lumen lighting system. So, let's go to Project Settings. Inside the Rendering tab, let's look for Global Illumination. Let's move it to Lumen. Let's move the reflection to Lumen too. Detail tracing under Software Ray Tracing mode. And we leave everything else unchanged. Let's get rid of the directional light that we had temporarily put on. The first thing you see is the lit objects, precisely because of the global illumination and because of the type of materials that we have created. As in the master material, if you remember, we have added a node. Emissive color. Emissive color, as I said in the lecture on global illumination, it allows the object, the material, to emit a type of colored light. This we have set for a fine-tuning. Because our scene has very diffused lighting, very soft global illumination, and this will help us, and soon you will see how. First of all, let's insert a post-processed material on stage. We can insert it into the scene at any coordinate. The important thing is that we activate Infinite Extend. Post-processing volume affects the whole scene. In the exposure section, we set the exposure to basic. Minimum exposure 1, maximum exposure 1. We begin to insert the first lights into the scene. So, create lights rect light. As seen in the lesson on lights. Let's talk about the rectangular light, which simulates a light emitted from a window or a square source. In one direction. It's a light that's right for us, because it is a very diffused and very soft light. Already with only one light you can notice how the level of realism of lumens is already very high. Let's set up a central light that occupies the entire wall on this side. Let's say the magnitude of this light. It must be the same as the missing wall. Let's duplicate it. We rotate it 90 degrees. And we are going to place it right above our scene. The scene has already taken on very good light. With just one use of two simple lights. This is absolutely the lumen that allows this type of rendering. We duplicate the scene again and place it on the other side, always in place of the missing wall. We are already very close to the desired result, simply with 3 lights in the field. We can then decide which is the main light. Maybe to go and adjust the brightness and intensity of the light a bit. For this scene, I recommend you to leave the color of the lights on white, and just remember to set everything up on movable. We duplicate the light on the right, take it out the window. And let's simulate the light that enters right through the window. We approach, we give her the correct size of the window. Let's go inside to see the result. As you can see, there is the shadow that the window creates. I would say we like it and we position it until we get the desired result. We can increase the intensity a little. I would say that is a generic lighting setting. We are already at an excellent point. Perhaps we can even say that this is the general rendering setup. We just have to do some fine-tuning. For example, we can still add other lights to dynamically move some parts of the scene, such as this one on the coin op. We can act on the attenuation radius so that the light only has an effect, as we saw in the previous lesson, on a limited area. We can lower the intensity. This area has already taken on a slightly more dynamic aspect. Let's go to further lower the intensity. To turn the light on and off, my advice is to use the effects world function to see the difference. Here if then, there is no real lighting technique. Here it goes a little to taste and sensitivity, and how you imagine the illuminated scene from the start. As our rendering is not photorealistic, with photorealistic subjects, we can have a lot more fun with lights. Let's see how to add a detail to the graphics tablet, just by painting thanks to the use of lights. Let's put a point light on stage. Let's place it right above the graphics tablet. The intensity must be reduced by a lot, even to a value of 0.05. And a radius which is the bare minimum to touch the tablet. And then we go to intervene on the source radius and on the source length. We rotate it 90 degrees. And let's create a reflection detail on the tablet. We make sure that it does not affect the other objects on stage. Let's disable the shadow cast for this light. And we added a detail to our scene. We can rotate it, calibrate it differently, increase the intensity. It can also be done by moving the object away. A piece of advice that I leave you before closing this lesson is to experiment and remind you that we, in our materials, we have added an emissive power channel, which allows us to control the intensity of the color a little, thanks to global illumination. By increasing it by 1, it even becomes bright. With 0.3 we make it much more alive than when it is completely off. Even a value of 0.1 is enough. The behavior is different from that obtained by lightening the color. The result is a much brighter and more dynamic shader. Now that everything is ready, we just have to bring the scene to life. In the next lesson, we will start with animation. Creation of gravity dynamics. In this lesson, I will show you how to animate the first part of the storyboard, the one where all objects are attracted towards a single point of gravity. To do this, we will use Blueprint. To explain how I made this system, I will proceed in a different way than in the other lessons. That is, I will want to see what I have already achieved, explaining to you step by step and not starting from scratch and making it together. Probably, for this lesson this system is more suitable. The prototype of this animation. I made it in a scene that you can find in the final project. And that you can download from the site. You can find it in the layer and maps. Gravity. Let's see what happens when we play the scene. These objects that are part of a blueprint class. They are attracted to this point. But between them and that point there is a sphere, which has a transparent material and has active collisions. Then they collide in that sphere and get stuck there. In reality, they don't get stuck, they just keep slipping, and to rotate around that sphere. The collision system. And how to get exactly the animation we want. We will see it in the next lesson. Now let's focus on how to create this dynamic. There are two blueprints that we need to create to make this work. You can find them in the final scene and download from the course resources. And then find them in the Blueprints folder. They are Blueprint Gravity Object and Blueprint Gravity Point. The Blueprint Gravity Object is the object class, which is attracted to this point. Let's go see what exactly I'm talking about. To create a blueprint class, just click on the right Blueprints button. We are just going to create an actor. In the meantime, let's see in the scene what is meant by blueprint classes. Let's go get all these cones. You can see above in the world outliner, which are nothing more than the replica of the blueprint gravity object of this class of blueprint. Once inserted in the scene, it is possible to decide which mesh will draw this blueprint. So all these objects are children of a single blueprint class. So if I went to change the properties of this class, they would change for everyone. But I made sure they diversified. And it was possible to customize the mesh that was going to be drawn. Then right-click Blueprint Class. The class we are interested in is a simple actor that I have already done, and I am going to open what I have already done, Blueprint Gravity. Once in our blueprint, we see that the only component we need, it is a static mesh. Here I have marked the name Gravity Object. To add a component, just click on the Add button. We need a static mesh, and we rename it as we like. As you can see, it is an empty static mesh, to which no geometry is assigned. What are the features we need? Surely in detail, we are going to set up. By first selecting Gravity Object in the Transform tab, we need to define this object as movable. In the static mesh we can select any mesh. For now it is only indicative and we will not have any changes. We can set any material, but at this point it will not vary, because the material will be inherited from the object in which we will then change, as we will see in a moment. The important thing is that in the Physics tab you go to Enable Simulate Physics and Enable Gravity. Always remember to fill in and save inside the blueprint form. We need to go and define the function in the construction script. As mentioned in previous lessons, the construction script deals with defining some rules that we are going to set up, but that are not activated when we play the scene, but only in the viewport and during the editor of our scene. We must first create a Set Static Mesh node, which allows us to change the parameters of our static mesh. Then right-click, Static Mesh Set. The knot we need is this. If we first created the static mesh in the component, Unreal automatically connects in the target of this node, our static mesh. In case it does not do it automatically, then just drag our static mesh into the blueprint and snap it into the target. The exec node must be hooked to our node and define which is the new mesh that we want to change within the component. To do this, we need a variable. As in the previous lesson, it is created by clicking on this plus button, and the variable is given a name, defining the type of variable. This type of variable is a static mesh variable. As you can see, I have already done this. I gave it the name setMesh. There is one important thing to do. It is compiled in order to display the default value. Then instance editable must be enabled. What does it mean? Just what we saw a little while ago. Once the static mesh enters the scene, I will be exposed to the value of that setMesh variable. It is a variable of type mesh, so it automatically makes this window available to me, from which I can select any mesh I have in the content browser. You can put the pyramid, or even the ones I created for our project. That's it as far as creating a blueprint class is concerned. So we have now created the blueprint class. It is called Blueprint Gravity Object, to which we have assigned these few rules. Let's go now to see how the attraction towards this point is defined. Another blueprint of type actor is created. I have already created it, and let's see how I did it. Let's focus on this central part. We will see these other parts later. First of all, the event is triggered by the event, in fact, event tick. That is an event that occurs with each frame that is calculated. If our scene goes to 25 frames, in a second we will have 25 ticks. So each tick calls this node, which is get all actors of class. Like all nodes, we enter it with the right button. Get all actors of class. What does it mean? It means that it goes to recall all the objects on stage belonging to a certain class. So once the node is inserted, once the exec nodes are joined between the event tick and this node, let's define which classes we are going to call. We have already created our blueprint class, which is called Blueprint Gravity Object, and Unreal helps us inserting it already in this window. The system at each tick will check the actors of this class. It will create an array, which in programming is an object, which contains multiple variables. Then calling the for each loop node. Always the same way, right-click for each loop. The system cyclically scans this array. And we can extract from this array, from this set of variables, the variable we need. Let's take the array element node, and let's go and look for the object we need. Because we know his name, why we called him that before. Gravity object. What is this step for? We just need to find in this array the object we need. In this case, we are talking about the object that we have inserted into the scene. And here we are already well underway because we have already extracted a very important information, that is our object. From here we can determine all the characteristics of this object. For example, where it is at the moment. It is important that you explain what the idea is before going on, and what we're going to do. To make objects move, this node comes in handy. Physics linear velocity set. What does it mean? It means that we can define the speed with which an object moves along a vector. What is a vector? Let's imagine a vector, in our case, as a line starting from the center of an object and goes in one direction. In our case, what do we want to do? We want to determine a vector that goes from our center of the object to the center of the object it attracts. So we need to know the position of our object and the location of the gravity point. At this point we can draw a vector. To have a vector we need the x, y and z coordinates, which determine the direction. Unreal comes to our aid with several functions. First, we need to know the place of origin of the gravity object. The getWorldLocation node comes to meet us. We can always call the same getWorldLocation node We attach the node to the target node or object. At this point, we will have the position value. Let's duplicate this node. And let's determine the position of our sphere. What do we mean by sphere? A sphere that we have already inserted as a component in this actor, which is then the center of the gravity point. So we have this position now, and we have this position. So repeating, we now have these two coordinates, the object and the point of attraction. Once again, Unreal comes to our aid with a fundamental knot. Fine look at rotation. Fine look at rotation is called up in the same way. What does it mean? This node to which we will apply a start the get world location value of our gravity object and target the center of our sphere. Another important thing is to recognize values that are passed between the nodes by color. Yellow are vectors. As you can see, vectors have three values x, y and z. So back to the find look at rotation, we will result in the exact rotation, which will point from object A to object B. At this point, with get forward vector, we are going to draw and define the vector. So at this point, once we have the two objects, and once we have the rotation of this axis, we can create this vector with get forward vector. It is given to us thanks to the rotation information. At this point we could already connect the node of this vector to the set physics linear velocity node. I repeat that the set physics linear velocity, it is that knot that allows us to have a constant speed in the direction of this vector. So we could link it. To multiply this value, we can drag the outgoing node from the get forward vector and multiply it with the multiply operator. But we need to change this input from vector to float. Then right-click, convert pin float. As I have already done, it is then necessary to create a variable of type float, which we will call power attraction and which we will make editable. Let's join them, save and go see what I'm talking about. Once this actor is selected, we will have exposed the value of power attraction. What changes? Change the speed, the value with which the linear velocity node manages the speed of movement of this object. Here I set it to 600, we can see at what speed they are attracted, with a multiplication of 600. Let's exaggerate, 1200 double. Animation is much faster. An important thing that we need to manage this animation later. It is still being able to not start it as soon as we press on play, but define a key that allows us to play and to activate this function. First, we need to call the enable input button. Connect it to the event begin play event, as we have seen in previous lessons, and connect the player controller to the get player controller node. It is easily recalled calling it as we already know. In this way, you are given the option to use the controls when the scene is in play. Instead, these nodes define which keys they start all the next function or not. Let's go back for a moment. How do we break this series of knots? Basically between the event tick event and the first node, which then triggers all the functions. Let's enter the branch node. What in programming would be if? That is, it gives us a condition. And therefore, only if this condition is true, we will go to perform all the calculations, otherwise, if false, everything will stop. Very simple. With this function we can recall any key on the keyboard. I chose the numeric keypad 0. Followed by the flip-flop node. What does it mean? Flip-flop is a branch, but with an exchange determined by pressing the button, so if I press the key, condition A will be true. When I take it back, B. If I take it back, it will be A. If I press it, it will be C. This means flip-flop back and forth. So when you press this key, we will have the two conditions A and B, which will determine if a Boolean variable I called and created on-off will it be true or false. A Boolean variable is a variable of type true or false. A variable is set by dragging the variable into the viewport and doing set. In this way, we are going to set the variable. To make this call, activate the variable. Just connect the node and select the condition of the variable. I repeated this operation, so on the first press, the variable is on and the second variable is off. The important thing is that this default variable is set to off, so that when you press the play button, when the scene starts, everything stays still. So what do we have now? We have a variable that varies according to the press of a key. We have this branch, an if. That is, it gives a true condition only if that variable is true. We just have to recall this variable. We drag it into the viewport get. That is, we are going to draw the value of that variable and connect it to the condition node. Because the branch node needs a condition. If this condition is true, this is true, and therefore this node works. If this condition is false, this is the exec node that will activate and nothing will happen. In the next lesson, we will configure the collision between objects. In this lesson, we will configure the collision between objects. To do this, we will use the physical material. Let's go. Once our blueprint is set up, let's see the result with all the default parameters. Sure, our scene works, objects are attracted and stop when they collide with the sphere. But they continue to be attracted. It is definitely not the result we want to achieve. We need to work on collisions. We have three things at our disposal. First, define what the geometries actually are, which affect collisions. You can do it from this window, player collision. So we see that it's not actually the mesh that draws the object, which defines the collision. But that's what we're seeing. Where do you control this function from? We had seen this in previous lessons. Just go to the property of the object. Our object editor, show, simple bound, opens. From here we see what geometry is colliding. It is not for us, because we don't need something that comes close to realism, but something that allows us to have a smoother, sweeter animation and less edgy. From the collision window, we are going to remove the collisions that are there. Now the object does not collide. It would fall on deaf ears if we started the scene in play. We have the possibility to add simple collisions. For example, a sphere. In this way, we save them and go and see how we have transformed collisions and how they arise. In the collision view, we see that for each geometry, we have a sphere as a collector. Let's see how it behaves. He is already better. He is less crazy, but there is still a lot to work on. We can work it this way. Inside the object editor, You can manipulate collisions as if they were other objects. So I can scale it, move it and duplicate it, holding down the Alt key. Let's try something like this: 2 balls. Let's see how animation behaves. I would say that we are there as a collision geometry. Obviously, when we go to define the final scene, where we will assign objects to each class of blueprint we should modify the collisions for each object and adapt them according to the object we are going to insert. It must be done for any type of object. Before going to define the surface properties, let's go change an Unreal setting. That is the interactions on collisions. Let's go to Project Settings. We search in Engine, the paragraph Physics, and scroll down until you get there to the settings of the Chaos Physics system. What interests us is iteration. What is meant by iteration? How many times collisions are calculated in an entire action, which can be a frame or a time frame. We don't need performance, we're not developing a game. The default iterations are 6, we can easily reach 60. To have a more precise calculation of collisions, let's see what has changed. Much better, but we have absolutely a bounce problem. How can we fix it? Going to define what Unreal calls physical material. It is a material that determines the physical characteristics of an object, which is then applied to the material. Let's go over this example object. Let's open its editor and see that this is the default material. Let's go find this material. And we see that a physical material can be applied in the properties. I've already done one, but I left the values set by default. In the final scene that you can download, you find it in the material folder. It's very simple. You can right-click Physics, Physical Material. At this point you have created a new physical material to be applied to any material. We repeat the operation. Let's go first to find the material of our object. And let's apply our physical material. There is only one in the content browser, so we can't go wrong. Now let's see the properties of this physical material. Double-click on physical material and its window opens. The settings we are interested in are friction. That is, the friction it has on other objects. We will set it to 0 because we want objects to slide over each other. Restitution is the bounce, that is how much they bounce. Objects on top of each other, and this value must also be set to 0. Let's see what has changed in our scene. We now have more interaction in the computation of physics. Therefore more accurate. We have rounder and therefore softer collision geometries. Objects no longer bounce and have no friction on each other. Then they slide and we got exactly the result we wanted. Objects are attracted all the time towards the central point of gravity and continue to slide over each other. We just have to replace, for each class of the gravity object, an object that we have modeled in previous lessons, remembering to then go and modify the collisions within each editor. We can also apply simple collisions that we are not, for example, the spheres. We can eliminate this collision by default and apply a capsule that perhaps best suits this geometry. Let's go test. And these objects work too. They are drawn in and their animation is soft. There is a bit of experimentation, and you have to calibrate the collisions above all. Once a scene has been set up well, so that these clicks do not occur, they are simply due to the type of collision a capsule has. But I would say that the result is more than good. In fact, by eliminating that object that had a somewhat stiff collision, the animation is soft again as it was before. My advice is to experiment and, for our case perhaps, ball colliders are the most suitable. In the next lesson, we will turn dynamic animations into keyframes. The bake of the animations. In this lesson, we will see how to transform dynamic animations in keyframes, the so-called bake. Thus we close the first part of the animation. Let's begin. Unreal provides us with a tool called Take Recorder. It can be activated from Settings plugin. And it's this plugin here, Take Recorder. I've already activated it, but if you haven't, you will be prompted to restart Unreal. Once restarted, in Window Cinematics, Take Recorder, we can activate this tool. The sequencer will automatically activate. For now you can close it. What is this Take Recorder? Take Recorder actually allows us to record, frame by frame, the movement of an object on stage. In this first screen, the objects to be registered must be entered, which are all our gravity objects. Select them all and drag them into this window. I'm 15 actor. Above, the first thing to set is the correct frame rate. Our whole project is set at 25 frames per second. In this second part of the screen, there are all the Take Recorder options. Fortunately, in our case, we can leave all information unchanged. The first part is about saving the sequence. So where, in which folder it will be saved, the name, etc. There is nothing to change for our needs. So we can go right now to see how it works. To record any sequence in Unreal, you have to play the scene first. And then, like any recording, click on the Rec button. Remember how we set up our blueprint? We need to click on the play button, and immediately, from the settings we have defined in the blueprint, press the 0 key on the numeric keypad, or whatever you have chosen to activate the gravity system. Play, the scene starts, I click the 0 key, and the gravity system starts working. Now we need to register this phase. As you can see, the mouse is now hooked to the camera. And so I can't press the Rec key. The Shift plus F1 key must be pressed at the same time to exit the camera control and to truly control the mouse. At this point, we can press the Rec key. Make the scene go on as long as we want. Then we have to drop the objects as per storyboard. So we have to go back inside the scene. Take possession of it, numeric keypad, and the objects start to fall. And we are done recording. We can exit the take recorder. And let's see the result of our take. By default, takes are recorded in the cinematics folder. Take. And the date they were registered. Double-click on the sequence and the sequencer opens. This is the first time you have seen the sequencer and we talk about it. We will deepen it in the next lesson, but for now let's see what the result is. We have traces. A track on a timeline for each object. Before seeing the result, you may have noticed that the items have doubled. Here the concept of spawn is introduced. In Unreal, a timeline is not directly connected to the objects on stage, or rather, it is not always connected to the objects on stage. Each object can have a spawn function. It means this: the object exists on stage only when the timeline head passes over it. This object, for example, exists alone and appears alone when the playhead enters the timeline. The take recorder makes those objects recorded. It duplicates them and makes them, as they say in the jargon, spawnable. So when we get out of the take, they don't exist, but the original objects remain on stage. My suggestion is to go to the World Outliner. Select the original objects. You can recognize them because they don't have this lightning bolt. The ones with the lightning bolt are the spawnable items, and you understand from the World Outliner that they are from this symbol. Which means that if there are, it is because somewhere there is a timeline that I brought up. I recommend selecting all non-spawnable items. Or rather, get out of the head so only they remain. Select them all. Go to the detail panel in the rendering box. Action hidden in game. So they no longer exist. We don't see them, at least they aren't rendered. And therefore they will be active only with the sequence. Now let's see what this sequence actually did. He recorded exactly everything that happened. All frame-by-frame movements of the objects we had selected and inserted into the take recorder. Now we can move on. Backwards. If we go to the end, we see the part of the animation they fall into. Our bumper is almost finished, only the final touches are missing, which we will see in the next unit. Camera management. In this lesson, we will animate the second part of the storyboard via sequencer. We will do this with a couple of examples. Let's begin. At the top, let's click on Cinematics. Add Master Sequence is what we need. After clicking on Add Master Sequence, this interface will open asking us, what is the name we have to give the master sequence? The suffix to have more master sequences. The path and the content browser. Where will these shots be saved and what is the number of shots? We need 4. For a project, you can leave all other settings unchanged. The duration of each single shot can be. Let's say we will initially leave it 5 seconds. Then cut it and trim it in the sequencer. Click on the Create Master Sequence button. The sequencer interface will automatically open, in which we will have already set up, in a row, all 4 of our shots. Let's see how the sequencer works and the logic. The sequencer works almost like any editing software. We have our timeline, our head, the lower part with all the options. The ones that interest us are the save icon. With this button we create a camera, but surely, it will be more convenient to create it in another system. With this key you can launch the render, but also here you will see it later in the following lessons, and we will adopt another rendering system. There are various options for viewing and managing frames. In short, all the options are already exposed. From here you can choose display rate, which by the way is not only display rate, but also the frame per second, with which we will then export this sequence. Here on the left, we have the shots object. It's a single object, you can't have 2. In fact, if we go to another it is not possible. As you can see, if I'm going to move a shot to set it to a lower level, it will simply duplicate the same object. And we will simply have 2 overlapping timelines. As I said, it works just like any other editing software. We can move our shots, move them out of sequence. We can cut them. Just place the head in the position we want and edit. We can do left trim, right trim, or cut right where the head is. We place everything as it was. Whenever the cartridge is over a shot, everything inside this timeline will be sent to play. Let's see how the shots work. Double-click a shot. The shot interface opens. On the right is the branching order of the master sequence. Compared to shots, clicking on the master sequence will go back, double-click. On the shot we will be inside the shot. Each shot features a camera cut. Camera cut refers to which camera is used and displayed when the head passes through it. Whenever you create a shot, a default camera is created. My suggestion is to create your own camera points. As you can see, I already have. Let's try camera 4 for example. I can select a camera, drag it into the sequencer, and then add this camera to the camera cut. These icons on the left allow us to activate in the viewport the view of the respective camera. Then, by clicking on camera 04, we will see exactly the result, as if we took possession of this camera. By clicking on the default camera that Unreal had activated for us, let's see the other camera. Instead, by activating this camera cut camera, we're going to just check the timeline, where we have selected the various cameras, so far we will see the result of the cinematic camera actor. As soon as we enter the cut that we have entered, we will enter camera 04. Hope this is clear to understand how cameras work in Unreal. My suggestion for our project is to start entering all machine stitches before creating the timelines. We know from the storyboard that the second chamber is the one that will follow, for example, our vase. Let's see how we set it up. Let's drag camera 01 into the shot. We check that it is the camera we want to use. We can cancel the camera we don't care about. And we have to reinsert the camera we want to display in the camera cut. Then we position ourselves in frame 0 and add camera 01 in new binding. So also in the master sequence you see that from the camera of shot 1. Let's move on to the second camera. In the next lesson we will see how to animate this camera and how to animate objects. One important thing is that in order to move the camera, to take possession of it and place it where we want, we must click on the icon of the little camera corresponding to the camera. We are now in control of it and can place it. Opening the drop-down menu of each object on a timeline, we have all the parameters to apply keyframes. The aperture, focal length and distance of focus. And then the transform options, which are position, rotation and scale. We can add parameters. For example, if we want to set keyframes for other options or parameters of our object. Let's go back to the master sequence. According to our storyboard, the first shot refers to the animation we built in the previous lesson, that is the dynamic one, for which we had recorded a take. So I delete the first shot. I'm going to look for the take which, as we have seen, we had recorded in the cinematic folder. Take. Now we can find the corresponding take and drag it directly into the master sequence. And then another thing to do is set up a camera for this sequence. This alert message tells us that some shot has a different frame rate than the master sequence. In fact, it's our sequence recorded with the take at 60 fps. At this point we can choose to work on the project at 60 fps. And therefore we no longer have that alert. For now it is important to create a new camera that it is positioned at this point. How do we do it? We click on this button. Create camera here. Let's create a sine camera actor. Automatically, Unreal will create a camera positioned exactly as we were oriented in the viewport. Let's move it to the cameras folder. Let's get into the shot we created earlier with dynamics. And insert the sine camera actor. As there was no camera previously in any camera cut, Unreal will automatically create a camera cut of the length of the sequence set on the camera that we have entered. So now, clicking on this icon, we can take possession of the camera and decide where to place it. For now, let's say we can place it here. Let's go back to the master sequence, and we see that exactly we have this correspondence. We probably want to delay this moment a bit to be able to enjoy the initial animation a little more. Let's go back to the master sequence, and let's cut this sequence when we are sure of its time. Let's cut at frame 0, right-click, edit. Trim left. Let's go back into our shot. And let's see that now the in and out of our shot. In the master sequence, we are indicated by this green bar that it is the in, so we know which portion of the shot is used in the master sequence. We begin to animate the camera. Our arrival position is this. At this point before they start to fall. So let's set the keyframe on the single axis we're interested in, the y-axis. Let's set the position on the starting y, I would say this. Let's see our first animation. So we will have a camera that goes backwards, which will be positioned exactly at this point. To be safe, I'd also set keyframes to rotation. We see that there is this problem of interpenetration, which we don't like. So since we have decided that this is the end point, we can insert a marker. Then right-click, add marker. We can delete these keyframes, position ourselves on the first frame, And maybe move here on the left so as not to interpenetrate with any object. Let's reinsert a new key program. Go to our marker. We set to the desired distance. Let's set up a new keyframe. At this point, we also insert frames on the rotation. On Y. And on rotations. So we have this starting zoom and we move backwards. Let's not stop the zoom out. Let's make it go beyond our marker. And place a frame at this point. At this point we will move this frame forward. So we will have a slowdown of the chamber when it gets to that point. From this point we will simulate the camera that follows the falling objects a bit. And we can do it through rotation. When we are sure, we also set the other location keys. Then zoom out. And we follow the falling objects. Let's go to work on fire, let's say right now. Cameras work like real cameras. Therefore, to have less depth of field, we have to set a very low aperture. Let's change the focus distance. Let's say we want it to be in focus at this point. Let's set the keyframe. While we want to start with the camera that is absolutely not in focus. The fire enters and we follow the objects. Let's go review the master sequence, then our project will start. With this animation, we follow the falling objects and go to the first camera, which we will animate in the next lesson. Now that you've turned dynamic animations into keyframes, we can move on to the next lesson, where we will take care of the animation through the sequencer. Animation of objects. At this point in the work, we just have to animate the rooms and do the setup inside the sequencer. Let's go. According to the storyboard, in this scene we would have a camera that moves backwards and the objects that fall from time to time in front of the room. Let's start, first of all, with the final position of the camera. Let's position ourselves in the frame where we want it to arrive, in this position, and we say this. Let's set the keyframe on the location. And on rotation. Let's go to the first frame. Obviously, The first frame will not be 0, but the first of this sequence, because, as we saw in the previous lesson, we cut it. Let's say we want to start from this shot, where we will see the cube fall. We insert other keyframes for the location and for the rotation. Let's say our animation can already be fine. There are only two details to take care of, namely the linearity of the room, because we want it to never stop but slow down when we get here. So, I'd say set a keyframe in this position to move here and move the last frame away. We now have a camera that comes in and then just slows down. Maybe we could move further away? This is the animation we like. We save. Now let's start inserting the objects into the scene. Before doing it, I would say to put, right away, all objects that interest us in the timeline. Then, let's take these two items, and we make them invisible so they don't bother. Let's start with the cube. So, I would say in this position, the cube may already have arrived. I placed it high. We could anticipate. And go create a little bounce. Keyframes, as you have seen, are inserted with the plus. You can duplicate them by holding down the Alt key. So we can duplicate the animation setting of the ZS. Take a little jump at this point, and then let it fall back. Let's just add the rotation. And we say that in this point it is neutral. At this point it is taken and agitated in this way. We still have to work on it, but to understand the system in which we animate, that's just fine. If we are not happy with the animation that we can get through the keyframes in this timeline, we can use curves. For example, in this way we select the parameter we want. We click on this icon, and we will have the curve of that parameter. Like all animation programs, find all the parameters to edit the curves. We can move on to the book. Let's say the book finished its animation here. Same thing, let's apply frames by position and rotation. In this point, He will also bounce a bit and then return to his position. Let's add the rotation. In this case, if we are not satisfied, we can select our parameters and optimize through the curves. As you see, having set the fire in the last position, obviously the objects move away and are no longer in focus, but this is what we want and we like it. Let's go insert the coffee. Let's say it will be in position, in stasis, more or less here. We are going to attribute the position and rotation frame. But, in this case, also of scale, because we want it to deform when falling. Here we have our object out of scope. Let's also animate the staircase. Here the curves meet us. They are easier to handle for this type of animation. Then we select the scale, we go into the curves. And let's go check out this animation. Now the camera moves back and the objects fall and enter the scene. This animation is not good. It should be reviewed with regard to the curves. We now have a full animation, where the camera recoils. And our objects enter the scene. I have one last thing to fix. This is our tablet enters the field. But we don't want it to be seen. We can insert it in the timeline, add a track. Action hidden in game. And disable it by inserting a keyframe. so that, once you leave this scene, you will be visible again. By applying these very simple techniques, you can animate all the other objects in the scene. Now everything is ready to start the next lesson, where I will show you how to animate the room and create the different shots for your animation. The post-processing volume. Our work is almost done. Just a little touch of color correction is missing, and then we can launch the final render. To do this, we will use post-processing volume. Normally this phase is done after rendering. That is post-production, color correction, compositing and color grading. In fact, Unreal gives us the ability to do it sooner and not having to intervene on the final render. The post-processing volume comes in handy. The name suggests it's post-processing even if it's done before rendering. We have also used it in previous lessons, but only as an aid in the viewport. Now we're going to use it just for the reason it's done. That is post-processing and fine-tuning of the image. Once inserted into the scene, it will appear as a volume. I have already set it up and scaled it so that it takes up the whole scene. This is just to show you why a volume is and how it works. Select Post-Process. In the Post-Process Volume Settings section, it is important that there is Enable. How does it work? Post-process volume only works when the camera is inside the volume. As you can see, if I go out, it has no effect. Entering the volume, all the options come into operation, which I have selected in the post-process volume. This is because it is very useful in the video game, but I must say it could also be useful in our field. Maybe one section with respect to another may have small differences, post-processing and color grading for example. But we can do this thing. Still in the post-process volume settings section, we can enable infinite extend or unbound. Basically, the options of this post-processing, they are valid for the whole scene, and it is no longer necessary to enter the box. Let's see what we can do and how post-processing helps us. Let's start from the first options, from the lens options. Those that are meant precisely in the virtual lens of the hypothetical room. Bloom is a classic bloom effect. We can change in intensity, or even in the calculation that is made to display it. Convolution is a much more realistic calculation, and indeed some options are disabled. For our scene, I recommend standard in order to calibrate to your liking. Even in an unrealistic way, this effect. The Advanced tab has a lot more options. You can also customize the bloom color. In our case, it is not necessary. Exposure, on the other hand, is very important. The auto exposure histogram option, which varies only for the type of calculation, it is that option that allows us to have the eye adaptation effect. If we are in a scene outside with a lot of sun and then we go inside, automatically the exposure will be set to always have the right exposure. As mentioned in previous lessons, what to do to have more control? Precisely because we do not need this dynamics and this automatism, it is good to set auto exposure basic and set the minimum exposure maximum exposure to 1, so as not to have variations at any point we put ourselves. Another effect we can use is the chromatic aberration. This too usually applies in post and is that effect, which gives a little more realism, a little more dynamism to the image, which simulates the error that cameras usually have when they shift, as you can see now that the stop expanding, the RGB channels. I have applied very little of it. You can change the intensity and the offset. By offset we mean it is as if it were a mask that starts from the center of the image, and therefore, the more you increase, the more the chromatic aberration. It intervenes only outside the image, not in the center. Dirt mask, we're not going to use it, but it simulates dirt in the lens. You can see an image or simulate spots. Or anything can be placed on the lens. The camera settings do not matter to us because we have set them for each single room. Lens flares is the classic lens flare, surely you have seen in 1,000 other applications. Image effect allows us to simulate a vignette. Or the grain. The same as the depth of field, we have already calibrated it in the various chambers, so we don't care. Color grading is a very interesting part. You can intervene on the white balance. So we can have a colder image or a warmer one. Or have the canonical 6500 Kelvin. But I changed it to 6000 because it is more suitable for our case. In global you can intervene individually on the various options, such as saturation, contrast, gamma, GAN and offset, according to the various RGB channels. In global we work on the entire image, while on shadow, midtones and highlights, it is the classic color grading intervention. Then we work on the darkest parts. On midtones and highlights. Don't confuse shadow with real calculated shadows. By shadow we mean the darkest parts. The only surgery I've done here is to set the shadow from 1 to 1.5 to make them a little less clear-cut. In fact, it does not intervene only in the shadows, as you can see from the black part of the monitor, to not have that intense black and have something a little softer. Movies are options, which give the typical effects of cinema film. Feel free to play with these effects and use them however you like. Another very important section is that of global illumination. The important thing is that once lumen is enabled, under global illumination method there is lumen, and that the global illumination quality is set to 2. The ray tracing global illumination does not need to be changed because it would have no effect. Reflection must be set to lumen and quality to lumen. In the rendering features section there are very important things not yet enabled on lumen. For example, it is not yet possible, being lumen in a beta phase, intervene on the ambient occlusion for example. Even by changing these parameters there is no benefit. Another important thing is the motion blur. We are defining the strength and intensity of motion blur that we want to have in our scene. For the rest, everything must be left unchanged because lumen automatically sets these parameters. I would say that's it as far as the post-processing phase is concerned. Have fun studying the post-process volume for a while to experiment by seeing what changes there are in the scene by modifying the various parameters. I just add one thing that can be useful, the view mode system. We haven't addressed it so far, but it could be very important. View mode allows you to have an image in lit. It means with the actual render, and it shows us what the final render will look like. Unlit is an approximation, and we will only see the colors of the scene. Wireframe, the word itself says, let's look at the wireframe of the scene. Detail lighting and lighting only are two very useful options. During the lighting phase, you may feel the need not to be distracted by reflections from various materials to focus only on the use of light. Detail lighting and lighting only differ in some respects, like the bounce of colors and, for example, the micro shadows of the normal maps. We have already seen layer collision, which allows us to see which collisions are actually on the scene, and many other possibilities. In buffer visualization overview you can have an overview of the various separate channels. You can see the roughness, i.e. all the roughness maps, all metallic maps, the opacities and all the others. In a testing and debugging phase, it might be useful to know the various view mode systems. In the next lesson we will see how to set the movie render queue to get the best possible rendering. Final render. We are at the end of our project, but one last thing is missing. Set up the movie render queue correctly. For the final render, let's go. The movie render queue is a plugin that must be activated, and it is not active by default. As with the other plugins, just go to Settings, Plugins, and enable the movie render queue. Again, you will be prompted to restart Unreal Engine. Once restarted, you can invoke it from the window. Cinematics Movie Render Queue. On first launch, it will look like this. The only usable key is the render key, which will indicate to the movie render queue what is the sequence we want to render. From the sequencer we can double-check the names of the shots we used, and also that of the master sequence. We want to render the entire master sequence, and, automatically, we will have applied it to a render queue. But if we wanted to render each shot separately, to then mount them for example with another software, we should create a real render queue. In this way, we should apply the first one, then add the other shots below for example. In this way, with only one render, all other shots will be rendered in the queue. Let's look at what the settings options are. By clicking on this icon, however, we can see what the shots are involved in this render. Unreal will check which ones are in the timeline and will indicate them below. On unsaved settings, the rendering settings window will open. In the output section, we can decide what kind of output the software should write. By default we will be presented with the JPEG, but we can then always add them from the settings button. In output we can choose whether to render in PNG, in bitmap, or other codecs, for example in Apple ProRes. But for the Apple ProRes the principle of the previous plugin still applies. That is, you need to enable it from the plugins window. We leave JPEG, which is fine anyway. Deferred rendering takes care of the basic rendering options. We can also enable alpha, but we don't need it right now, because our project, it is born and ends in the sense that the final render is the output we will get from Unreal, so we don't need to do compositing with other software. Therefore it is not necessary to enable the alpha. In the last output window, it is decided where to set the render, what the various files should be called. With this naming convention, we will have the sequence name, and then the frame number, the resolution of the output, the frame rate if we want to change it. By not using this check, the value set in the sequencer will be used. Otherwise you can customize it. You can decide not to render every frame, to render frame steps, or to customize the start and the end in our rendering. However, there are many more options we can use to optimize our rendering. For example, one of the most important is anti-aliasing. By not enabling this option, we will have the temporal anti-aliasing you saw in the viewport. A very important thing for rendering is, since we don't care about performance in real time, we can raise these parameters. In our case, I recommend that you use values of 8 and 8 on sample count and the temporal sample, and to enable overwrite anti-aliasing, and to set the anti-aliasing method to none. The more we increase these values, the more the rendering quality increases. Note, however, that these two numbers will multiply, so each frame will be calculated 64 times. High resolution is used when you want to split the rendering on different screens. For example, if you are working on a video wall with 2, 4 or 8 screens, you can split the rendering in this way and with this option. The other options refer to a path system. What does it mean? It means that the object IDs can be rendered separately. Different paths can be rendered separately, such as specularity, ambient occlusion, etc. Say we have dealt with almost all movie render queue settings. At this point, all that remains is to click on Accept. And we can already launch the rendering. A very useful thing is that we can save each setting. Returning to Settings, Presets, we can choose to save our preset with a name like Preset Render. 8x8 Anti-aliasing. At this point, we can call it back at any time. We just have to launch our render. This window will open. It is important to know that you are going to view. It is a low-resolution preview and is not authentic for the final result. On the right side, the number of frames is counted, referring to the shot being rendered. Our first is that of the sequence 05001. The first 10 frames of 449 were taken. Subsamples refer precisely to the times a frame is recalculated. According to the anti-aliasing settings, as I said before, each frame is calculated 4 times. In fact, every 64 render a frame is generated. On the left, in the overall section, instead the total percentage relative to our sequence master is indicated. Our work is done. The result is a colorful, fun and dynamic bumper. Just like the Domestika community. Try making a bumper like this yourself. Have fun creating new scenes and inserting new objects. I am very curious to see your result in the forum. In the next video, we will review all the main steps of the course. Final project. Our course is over. First, I would like to thank you for following my lessons and having made this journey with me, discovering Unreal Engine 5. During class, I tried to show you that by studying the right technique, you can transform your every idea into something concrete and animated. First comes the idea, then the tool. Too many times I see works influenced by the instrument, and this is not good. Technical knowledge gives you more freedom to express yourself, but above all it serves to obtain the desired result. This course, in fact, has not been expressly designed to explain how Unreal Engine 5 works, but to give you the basics of understanding real-time graphics and the infinite potential it can offer you. The final project has some characteristics which serve to introduce you the basic concepts of real-time graphics. Thanks to the intro made with dynamic animation, via programming, the use of global illumination and the hand-animated part, you will have acquired the tools to experiment and, why not, have fun. Now, in fact, your time has come. The challenge for you is to create your own animation. Don't just copy mine, create something new. First, study the various modules of Unreal and get familiar with the software to fully exploit all its potential. Then think about what you want to tell. Even the shortest story needs to be visualized and divided into key scenes. Start by modeling the simplest objects. Move them on stage and move the cameras to create your shots. If at first it seems so difficult, follow my example, but remember that even the smallest detail can make a difference. So don't give up and show me your final project in the forum. I'm curious to see what you have accomplished. I hope that you too, thanks to this course, found the tools to bring your ideas to life.